What's up, everybody? It's Eric from Dark MatterX, and you're probably wondering, what the heck is this thing? Well, if you've been following us on our social media or our Discord channel, then you already know it's a prototype, full-blown shift replacement for the 2015 plus WRX. We're getting it ready right now to test in the 2022 WRX. And while brainstorming ideas, I like to use tools like CAD, 3D printing, CNC machining, and even other languages to create this beast of a shifter. On the left here, we have the prototype design, and on the right, we have the OEM Subaru design. Let's go over some of the differences between the two. This prototype is built directly off of the existing DM1 platform, okay, currently available for STIs and older generation WRXs. Like the DM1, it replaces the entire OEM shift assembly. Okay, I remember this was one of the first things I noticed when I drove a newer WRX with the cable shifting transmissions. When I was going in and out of gears, didn't even feel like I was shifting. It just felt like I was putting the shifter where I knew it was supposed to go, and then the car was just kind of going into gear. There's no real engagement there, and so this was something I wanted to solve. And I did that by getting rid of the cable and replacing it with a piece of linkage. Okay, let's cover the shift stop design differences between the prototype and the OEM shifter. Now on the prototype, we have one shift stop on the front, and we have one shift stop on the rear. Each stop provides 2 points of contact, so that's a total of 4 points of engagement when they're being used on the prototype shifter. On the OEM shifter, we only get one stop from the factory. And you may have upgraded and put another stop over here, and that's great. Now you have a shift stop on each side, but what actually makes them completely different is how they're designed. On the OEM shifter, we have what's called kinetic friction in between the shifter and the shift stop itself. Because one of them is stationary, what happens is it hits the other and it slides along it. And depending on how hard you're shifting and the types of material that they're made of, this will determine how quickly they start to wear out from that kinetic friction. And I've actually seen the aftermarket upgraded shifters where they're metal and the shift stop is also metal, and this will create a lot of friction over time and start to wear the two pretty quickly. And on the prototype over here, we have the shift stops located on the axis, and they can actually pivot with the shifter. So there's absolutely no kinetic friction in between the two surfaces, and this is what makes the shift stop design so different from the OEM design. Okay, and finally, let's talk about this billet aluminum lever on the bottom of the shifter. Now it connects to the shifter through a series of rod ends here and here, and it connects to the OEM push-pull cable right here with an inline rod end, and it pivots on the shifter right here with an Enduro radial max ball bearing, just like the rest of the U-joint on the existing DM1 design. And on the top, we have it preloaded up against a polymer IGUS thrust bearing to give it some extra support in the Z direction. And by measuring the forces from the push-pull cable and the push-pull cable lever on the transmission itself, I was able to apply this into some finite element analysis and help optimize the design and the shape of what this lever needed to be to create the minimum amount of deflection at the end. And we know from the beginning of the video that math equals car parts. So by using everybody's favorite subject, the relative left and right shift angle movement was able to be properly designed into this lever. All right, everyone, that is the end of the video. I hope you learned something today. I'll be doing more updates as we get the shifter in the vehicle, start testing it. If there's anything you want to see changed, anything you don't like about your current shifter, let me know down in the comments below or in the Discord.